Thank you, Eamon. Hello, everyone, and welcome all. You're doing well. I'd just like to thank the Better Energy Homes team for inviting me to do this webinar on cavity wall insulation. My name is Michael Lennon, and I work as an inspector across several SEAI schemes. And I suppose this session is going to be an opportunity for myself to share some of my insights that we've gathered during inspections on cavity wall installation. So we're going to focus on providing clear guidance for cavity wall insulation work supported by the programme. And as I said, there's a Q&A section. There is other members of the panel there that will be able to answer the questions. So if you think of something during the presentation, just pop it in there and you might get a response as we're going through. So we look at the agenda, and as I said, we're going to look towards ventilation. I suppose as part of any wall upgrade, ventilation would be a key part of that. So we're going to look at the standards and requirements. Location of bead drill holes in relation to cavity wall. There is the guidance that we'll be touching on in relation to a second wall measure that would make a home compliant with grant programme. Common reworks that we'd see during inspections and how to avoid. And then, of course, we'll just be pointing you back to maybe some of the supports available to yourselves, as well as answering any questions you may have. So we're going to start with the wall ventilation standards and requirements. And delivering high quality service is essential to the grant funded works. So we encourage you guys to familiarise yourself with the documents. And they're all available on the support section. So a key document would be the domestic technical standards and specifications. So it's a good reference for you guys carrying out the upgrade works supported by the programme. There's also the code of practice that sets out guidelines, different standards for your registered contractors to adhere to. There's also the QADP, Quality Assurance and Disciplinary Procedures. And that particular document would contain what I would class as important information for you guys, checklists for cavity wall insulation and other upgrade measures. So I would encourage you guys to look at these checklists. These are the exact same checklists we'd use for an inspection. And it may be to give yourselves an opportunity to inspect your own work prior to sign off to avoid any reworks. We also look towards technical guidance document part F for ventilation. That sets out the different ventilation types in buildings, ensures that adequate ventilation is met for buildings and roofs, etc. So we'll be looking towards the guidance set out in that document, as well as the SR 54 or the practice for the energy efficient retrofitted dwelling. So again, to understand this document is essential for any retrofit project. So it contains technical guidance, it covers different retrofits, specifically in the Irish climate in mind. And there is a section in there on cavity wall installations as well as external, internal wall, other measures that you may be familiar with. So I suppose prior to any retrofit and dealing with existing buildings, the majority of existing buildings may already have some sort of traditional forms of ventilation provided. So homeowners may already have purpose-provided natural ventilation, whether it be a vent in the wall or a vent in the window. So I suppose it's your responsibility for when you're undergoing a cavity wall installation that your works don't compromise the existing ventilation that's present already in the building. And I suppose when you're looking at the job, your discussions with a homeowner will be fairly important to advise them on the installation and what kind of vents may be required to achieve compliance. And it would be a good opportunity as well to explain the benefits of proper ventilation in the building, improved air quality, reduction of condensation risks in the building. So it would be definitely part of your discussions with the homeowner to highlight the benefits of getting the insulation as well as the ventilation installed. And of course, you're going to specify the works required to achieve compliance. So that's going to be linking back in with your discussions with the homeowner in relation to what vents are needed to achieve compliance. So we're talking about looking out for what you see in here. So examples of existing background ventilators, permanent ventilators, whether it be in the wall or in the floor vents. You're looking out for what exactly is existing in the building. When it comes to windows, building may already have existing trickle vents and windows, so you're watching out for that. And when you're in relation to wet rooms, you might see situations where bathrooms, shower rooms, en suites, etc., has existing extract ventilation, as well as cooker hoods in kitchens as well. So you're looking out for these existing ventilation already present. So again, these are examples of blocked ventilators. So again, it would be part of your work to inspect and service any existing ventilation that's present. So you're making sure that when the installation goes ahead, cavity beads are pumped in, that the vents are sleeved, the existing vent isn't compromised, that kind of thing. You're watching out for that. But we always look back towards the guidance that's provided to us. And this particular table here is from SR 54, table 30. And it's the guidance for provision of ventilation for retrofit works. So we're looking at specifically what we're doing here. We're doing the cavity wall insulation install. So that's our retrofit works. And if we look at scenario A highlighted here, this is, for example, where you're pumping the walls and you have a situation with a home with no existing background ventilation. So you see there here it's highlighted that you be requirement to install background ventilation. There's also a requirement to provide extract ventilation to the wet rooms if there's none existing. You look at scenario B, where you come across where there's purpose provided background ventilation. So you're coming across existing vents. If there's existing vents already, there's no requirement to install any additional vents. Just need to make sure that they're fully working and serviced. But there is a requirement to install mechanical ventilation or extract ventilation in wet rooms. So again, if there's any signs of mold or condensation in wet rooms, it would be a requirement to install mechanical extract ventilation if it isn't present already. And then the next scenario C would be an example of a home that you may retrofit where there's existing ventilation present, whether it be a background ventilator in a habitable room or mechanical or extract ventilation in a wet room. So again, you can see here it highlights that there's no requirement to provide further ventilation if the ventilation is already existing. So as long as it's not compromised during the work, there's no requirement to install any further ventilation. And that's where we take the guidance from. Table 31 goes a little bit further and it specifies the minimum levels of background and extract ventilation, and it depends on the room type. So we take an example here for a habitable room. So that's a room used for living or sleeping in, and you're talking about your bedrooms, living rooms, office spaces, etc. And so it is a requirement to provide 6,500 millimeters squared of free air, and there was no requirement to install extract ventilation. So you're talking about a background ventilator in habitable room if none present. Move on to a kitchen, for example. It specifies that you need 6,500 millimeters of free air and also extract ventilation. So that would be a 60 litre per second fan rated for the kitchen, and that could be reduced to a 30 litre per second fan if it is a cooker hood that's suitably located as well. So again, that's the specification for kitchens. We move on to a utility room. Again, it specifies both a background ventilator providing 6,500 millimeters squared of free air and also extract ventilation, which happens to be a 30 litre per second fan in the bathroom. So it does also specify that if there is no external wall, say if there's limited space in the utility room, and if the floor area is less than 6.5 meters squared, for instance, if background ventilation cannot be provided, then it would be another option for you to install an extractor fan to operate with a 15-minute overrun. And that might be typical in utility rooms where space is limited, maybe to get both vents installed. And then you're moving on to wet rooms such as shower rooms and bathrooms. So again, it specifies that there's no requirement for background ventilator in this room, but there is a requirement for a 15 litre per second fan. And again, it has the side note there as well about a 15-minute overrun similar to utility room. And the last one would be a WC. Again, there's no requirement for a background ventilator, and a 6 litre per second fan would be required there. Also, side note C, where a window opening for purge ventilation exists, the window alone may be relied upon for extract ventilation. So again, you're assessing the different room types, assessing the existing insulation or ventilation, and if there's none present, just specifying the correct amount as detailed there in table 31. You have to think and question yourself as well on any cavity wall install. Is there an open fluid appliance present in the dwelling? So again, the part of your discussions at the beginning with the homeowner. But if you take this scenario where you're retrofitting wall insulation, scenario A, if there's no existing supply of air into the room that has the open fluid appliance, then there is a requirement for permanent ventilation. So again, combustion needs to draw air from the room in which it's located. So if there's no airflow into that room, you have to provide a permanent vent into that room. So again, this highlights the importance of having permanent ventilation when you have open fluid appliances. So that's something you're assessing as well and keeping an eye out on. If there is already an existing vent into that room, if there's an adequate supply of air containing in a room with an open fluid appliance, then there's no requirement to install a new permanent vent, but it'd be recommended, again, to ensure that the ventilation is unblocked, good condition, permanently open. So it may be the case that you might have to, if there's a closable cover, it may need a permanent cover in a room with an open fluid appliance. And again, that'll be part of your work to make sure that the vent has an adequate air supply into the room containing an open fluid appliance. So there's a great guidance note available on the SEAI website in the supports for contractor section. It details exactly what vent is required for each room type. So that's definitely something that I would look at having printed off, maybe readily available in the van, just to do a quick check on what is needed for each room type. I would even potentially show the homeowner this if you wanted to maybe explain how to get compliance under the grant and what vent is needed. It'd be something that'd be nice to show them as well as part of what is needed for compliance. So we'll move on to location of bead drill holes for cavity wall installation. So again, as installers, you must follow the installation procedure outlined in your NSAI agreement certificate for the system that you're installing. So the drill pattern itself should be continued all the way across the wall unless it's overridden by a drill pattern associated with a window and door. So we're going to look at some examples taken from a typical dwelling here on a typical NSAI agreement cert. So we're looking at a situation where we have a detached property without existing insulation. So there's no existing insulation in the cavity already. We're looking at having 2 meter spacings. The gap will be 600 to 650 millimeter spacings under the soffit and windows. Again, if it's a gable, we would just allow for 200 millimeters above the ceiling level in order to fill the wall correctly, and that's what would be specified in most NSI certificates. When you're talking about side walls, say under soffit, you'd be required to drill 200 millimeters under the soffit level. And where we have situations where we might have a room and roof or asset conversions, we're talking about insulating that triangular peak section all the way up to the ridge level. I suppose as part of a conversion, the occupied rooms would be affected up all the way till the peak there. So it would be required to do a whole house elevation there all the way up to the peak. The next one, slightly different, where we have an existing building with existing. So you might have a partial fill insulation in the cavity. So again, 1.7 meters to 1.8 meters between the rows at the 1.2 spacings. 600 millimeters, so slightly different than the last one. 600 millimeter spacings under the soffit and windows. 200 millimeter above the ceiling on a gable, for example. 200 millimeter below the soffit, and same if there is a room and roof or a dormer or attic conversion, those gables that have heat loss walls would need insulation all the way up to above the ceiling level all the way up to the gable peak. So some different situations that will require different drill holes to ensure the installation procedure is correct. We're talking about under flues, for example, under vents, so any existing wall vents or new wall vents that's being installed. If there's an ESB meter cabinet, for example, that needs to be drilled underneath, being mindful of cables. And then either side of openings like windows and doors. So that was exactly kind of the extra areas that would require additional drill holes. If you take what an inspector would look out for, the inspector's looking out for exactly that. We're looking for the cavity wall installed to have a drill pattern that would be applicable to the SEAI cert that was provided to the homeowner. So again, whatever product has been installed, we would expect the SEAI certificate to be left with the homeowner and to be available for an inspector. An inspector would check what exactly the drill hole or the drill pattern would be present, and we'd be highlighting potential issues with this home where the drill pattern isn't exactly as per SEAI certificate. So the inspector would be looking towards exactly what holes have been drilled on an install. So common reworks and how to avoid, we'll look at different sections that we'll be looking at during an inspection. And one of the first areas would be the wall area to be filled. So we're talking about, in order to be grant compliant, a whole house or whole surface solution must be provided to the homeowner, and that would include any extensions, and in order for the homeowner to be eligible for the grant support. So again, as part of your discussions with the homeowner, the difference must be explained between affordability and economic viability. So where the homeowner indicates that they cannot afford, say, a whole house solution, this would not diminish the viability of the installation, and it's not acceptable. It's not an acceptable reason for not to be complete a whole surface solution. So in order to be grant compliant, it should be the whole surface solution. So we're looking at this particular example that's highlighted here, where potentially you have an attic room and roof conversion. If we have habitable occupied rooms upstairs, will be a requirement for the drill pattern to go all the way up to the gable peak there in order for it to be properly filled and to achieve the whole house solution. For example, the stone wall area may require an alternative wall insulation. For example, the homeowner may not want that to be drilled. So in order to get the whole surface solution, a different or alternative wall insulation may be installed in different sections of the home. We already touched on the drill pattern. So again, the left image is a screenshot from an SEAI certificate, and the right image is something that we'll be looking for during an inspection. So where are the holes drilled? Are they compliant with the SEAI certificate? Also, when it comes to sealing of the drill holes, I generally would ask the homeowner if they're happy with the finish as part of my interest with the homeowner. If they were happy with it, I generally be happy. But again, as installers, I would generally ask yourselves, would you be happy with it if it was on your own home? So we're trying to match the drill pattern and the wall color together. So the likes of this one being off center on the joints of the brick, or mortar purely matching the existing one as well. So it's just something to talk about with the homeowner. They might decide they want to paint the property after, or may not. It'll just be part of your discussions. So we're talking about good practice here, where we have good examples of the joints being drilled on the center, holes matching the existing facades, and especially where there is a dry dash wall to fill it and to make it match with the existing. So if there's any stones that need to be filled in with it, that'd be a good idea as well. Moving on to cavity brushes. So where there's a semi-detached or terrace property to be insulated, the insulation is contained by inserting a cavity barrier along the line dividing the different properties. So it consists of appropriately sized cavity brush, and after filling, the cavity barrier is retained and bead overspill is prevented. And so you might see cavity brushes being used for wall vents, flues, on suspended floors to prevent overflow of bead into those areas. And so we have an example of a typical borescope inspection that an inspector would undergo. Shows the presence of a cavity brush there as well. So that's something that the inspectors would look out for on terrace properties. We're moving on to situations where we have the tops of cavities capped or not capped. It would be something that would be required to prevent overspill of bead into attics, for example. So there's other reasons why cavity capping would be important. So we're talking about cost. So cost to you guys going back out, to remove this bead, or cost of the bead itself, bead waste, for example. It's messy. A lot of time might be involved in tidying up if this does occur. And it may be a situation where the bead is overspilled into an attic, for example, and may compromise the existing roof ventilation. So it can lead to these sort of problems, and the tops of the cavity should be capped prior to any cavity wall install. So we have a couple of examples here of what an inspector would see. And again, if that was identified during an inspection, it would be highlighted as a rework. Again, it's timely and costly for you guys to tidy up. Moving on to NSEAI agreement certs. Again, I mentioned these before, that these would need to be provided to the homeowners, along with a guarantee of the work that was completed. So again, it's something that the inspector would ask for as part of their inspection, as well as the declaration. And the declaration, again, should be highlighted or included to the homeowner. Should include the company headed paper, the date, address of the install, the area of the bead that was installed, including the depth. And again, other information like the product that was used, thermal conductivity, all be important for an inspector or even a BER assessor that was doing a BER on the home. So yeah, that needs to be provided to the homeowner. We look at ventilation examples during an inspection, and if we come across a habitable room that has an open fluid appliance, this example here, open fire, maybe the homeowner doesn't use it that often. Look, if there's a fireplace present, and if it is capable of supporting an open fire, we're talking about a permanent ventilator in the same room as an open fluid appliance. So again, must be installed in order to get grant compliance. We have situations where we may have oil boilers located internally. This particular example, it's not obvious where the boiler was located, hidden behind cabinets, etc. So again, it's something that the inspector would look out for. Different heating appliances, what kind of flue type is involved here. We have a situation where we have an oil boiler here that's connected to a chimney. It's an open fluid appliance. That appliance is drawing air from that room, so a permanent ventilator would be required. So we have a situation where we have a permanent vent not fitted, but it would have been a requirement. We have other open fluid appliance types, such as solid fuel range cookers. Again, this is burning fuel. There's a risk of carbon monoxide if the proper air supply isn't installed, so a permanent vent would be required on that particular one if there was a cavity wall installation. Looking towards wet rooms where we have cavity wall installed again. So we have mechanical ventilation vents not fitted but required. We also have the option where mechanical extract ventilation advisory note wasn't available. So we look towards either installing a wet room extract ventilation or discussing with the homeowner and getting them to sign mechanical ventilation waiver. So this would be an example of that waiver. An important safety notice, again, but this is linked on the supports for contractors page. So as part of your discussions with the homeowner, that they should be properly advised on the installation of mechanical extract ventilation and the options that best meet their household needs. So SEAI require that this notice is used where mechanical extract ventilation in wet rooms has not been installed. So before the installation of wall insulation, this should be discussed with the homeowner. They should be advised of what their best option is. Again, they should be advised that the best option would have extract ventilation installed, but if it wasn't installed, this document will need to be signed and retained with any documents and available for an inspector. So it's in your interest. I'd even suggest that you keep a copy of it yourself and send a copy or provide a copy to the homeowner as well if extract ventilation isn't installed. So we have situations where we have habitable rooms and no existing ventilation. So as an inspector, if this property had cavity wall insulation installed, the inspector would be looking for a background ventilator. So they'd usually check the outside of the building, check for ventilation in the windows, and again, it would be a requirement if for the background vent to be fitted. In wet rooms that contain open fluid appliances, it's a requirement that a mechanical extract vent isn't installed in the same room as an open fluid appliance. And so we might see situations where we have utility rooms that are wet rooms. That utility room might have an open fluid appliance in it. If that is the case, it is a requirement to have a permanent ventilator in that room if it is an open fluid appliance present. We have a situation here where we have a kitchen that contains a solid fuel open fluid appliance, range cooker. And again, we have a situation where a new mechanical vent was installed in the same room as an open fluid appliance. That's outlined here. So if that has happened, the extractor fan can remove air. It may cause the room to be underventilated. It may cause problems with combustion with the appliance. There's also a risk of carbon monoxide as well, or could be a risk of a flue backdrafting as well. So that's why it's not required to install extract ventilation in the same room as an open fluid appliance. It's something to watch out for and something that an inspector would look out for too. Again, we mentioned the vents at the beginning of the presentation. We have a situation where vent may be blocked or compromised by the cavity wall install. Again, as part of your work, you should be inspecting and servicing any existing vents to make sure they're properly sleeved, free from any blockages or obstructions. So again, if there's a blocked vent, it may lead to issues to do with condensation, mold buildup like we're seeing here. So that might only become evident months after the install. So it's definitely something that, if an inspector came across this scenario, it was definitely something that would be investigated further in relation to, is the vent actually working? Is it doing its job? So again, just serious concerns here over mold or condensation buildup. So it's just something to be mindful of where existing ventilation exists, not to compromise existing ventilation. Again, this one here, the vent was not sleeved, so it's clear from the outside there that the bead is compromising the vent, so the vent itself wasn't sleeved. Other examples like this. And of course, something that the inspector will watch out for. We have maybe not so common on newer builds, but on existing buildings, maybe older buildings might have suspended floors, especially in the front living room. So if a cavity wall installation is taking place, it's definitely something to watch out for where there's a suspended floor. I suppose you can see the vent towards the bottom of the wall there. If there was one of them present, it's definitely something that an inspector would look out for. A lot of the time, upon investigation of those vents, after an install, they may be filled with beads. So it's definitely something to watch out for. When it comes to mechanical extract vents, if they're maybe existing or installed, they should be, I suppose, properly ducted to external, and they must be insulated or under the quilt. So again, If they're passing through an attic space, for example, it should be insulated under the quilt. The duct runs themselves should have minimal bends, and the lengths. I suppose I would avoid flexible ducting if possible, or if you have to use flexible ducting, keep the lengths short as possible and fully pulled taut. I kind of prefer rigid ducting for its durability, but something to watch out for when you're installing extract ventilation to make sure that the fans are properly insulated or the ductwork is insulated and externally ducted as well. When it comes to wall penetrations, for example, gas connections, it's important to check that the walls are well sealed, watertight. If water, for example, was allowed to enter the cavity through openings on the external wall, if that would persist for an extended period of time, that could lead to dampness, mold, issues within the property. So you're talking about situations like gas connections, meters, flues, vents, all the scenarios where wall penetrations would exist. So as long as they're properly sealed, not allowing any water to enter. Another example would be around waste pipes as well. So just to watch out for that. It may cause problems over an extended period of time. Bead adhesive. So again, as something that you know about as part of your NSEAI certificate. Suppose the flow rates of the bead and adhesive should be checked as per your products that you installed. The amounts of adhesive that are applied to the bead should be checked against your NSEAI certificate. And we have a situation here where an inspector has picked up on ESP meter where the bead would not have enough adhesive. And if that's going to lead to further problems maybe down the line for a homeowner. For example, if they were removing windows or replacing openings over a period of time, if there isn't proper correct bead adhesive ratio, that might prevent, it might cause a lot of issues if with windows and doors if they're being replaced in the future. So again, the inspector will look out for that. Installation as per specifications, so it's details in the domestic technical standards and specifications. The target U value for each wall installation. So for cavity wall installation, it's 0.35 of the U value or better for the external walls. So again, that should be something that would be or would need to be achieved for grant compliance. It would be maybe something that you might want to discuss with the BEO assessor that's involved, but it'll all depend on the age of the property, the cavity width as well will determine if that U value is going to be met again. So again, there's a couple of things at play here. Is there a sufficient cavity present in order to install bead? What depth is the cavity? It'll all contribute towards what the U value is going to be. So it's definitely something that needs to be addressed for grant compliance. These type of borescope inspections are completed by the inspectors as well, just to verify what exactly was material that was used in the cavity. Again, that will be recorded on an inspection. Just be mindful as well of where existing fibre is present in the cavity. Look, if there's existing loose fibre material, for example, the cavity is already going to be filled with insulation. So again, you must check against your NSEAI certificate for the product as well, just to confirm that it can be certified. There's different types of fibre materials, just fibre batch materials, loose fibre materials. It all should be checked as part of your initial survey on the property, whether it's suitable to be filled. We come across situations where we have, for example, a gas meter. I suppose before work is carried out, it's important to identify any areas where bead spillage may occur. So again, this area may need to be cavity brushed. Again, we already talked about suspended floors and for that potentially to fill into a suspended floor. But we also have a situation where we have a gas meter here on the right hand side. that has been filled with bead. And again, that would be classed as a health and safety issue, as if it'd be difficult to turn off the gas if there was a leak, for example. So again, pay an extra attention to gas meters or areas where bead can spill, ESB meter cabinets, for example. So we're seeing a situation that would be require a rework, and this is exactly what we'd like to see here: the bead preventing from flowing into the ESB meter with a cavity brush. Also have boiler flues that may be compromised by the works themselves. So again, something to watch out for if it needs to be cavity brushed. So we move on to guidance regarding a second wall measure. And so specifying cavity wall insulation to achieve compliance. So it may require, some homes may require a second wall measure. We might have situations where you might have a home with a cavity wall that technically might be not feasible to fill. So there might be clogged cavities, there might be narrow cavities. Depends on the product that you're installing, but a lot of existing walls would need cavity depths not less than 40 millimeters. So again, that should be checked against your increment served. So if you have situations where a cavity wall is not functionally feasible, you may need a second wall measure to be installed. So mixed measure solutions. So internal wall insulation may need to be installed, or external wall insulation may need to be installed as well. Again, we're thinking about achieving compliance. So homes will need a whole house solution. Might be certain parts of the homes that aren't feasible to fill with cavity, for example, and they need to be addressed as part of a whole house solution. So this is an example of a cavity wall that is clogged, and I suppose that would be part of your initial survey to determine suitability. We have a situation where we have existing insulation here on the right-hand side image, but there would not be a residual cavity of 40 millimeters on that one. So again, that's something to look at. Is the cavity wall insulation feasible? If not, we're talking about doing a second wall measure to achieve compliance. So achieving that whole house solution, all heat loss walls. Any partial solutions that are on the property, that should be detailed in the declaration of works. So everything should be documented on the declaration of works, and you may need to inform the client that it may affect the grant eligibility if a full whole surface solution isn't achieved. Again, we're looking back towards compliance standards with the domestic technical standards and specifications. Make sure that the cavity wall type achieves the U value of 0.35 or better on all the external walls. And if that is not the case, if it doesn't achieve that U value, then you're talking about additional insulation or a second wall measure, which would be potentially internal insulation or external wall insulation. And that will make the U value achieve compliance for the grant payment. So if there's mixed measure solutions installed, again, that should be detailed in the declaration of works, outlining exactly what areas that were filled, what areas were filled, etc. The grants themselves will be for the greatest measure by wall area. So there may be situations where you have mixed measures on a property. If cavity wall insulation, for example, is the greatest measure, then that is the grant that is claimed for as part of the upgrades. Only one wall grant is going to be paid for non-grant aided works. So you might have situations where you might be installing cavity wall insulation, another supplier might be installing a different wall insulation. So you must not sign the declaration of works until all works are completed and say full coverage has been achieved, that whole house solution we're talking about. So we have an example here where mixed measure solutions are installed. So we have part cavity wall insulation, part internal wall insulation. So again, that's going to be detailed on the declaration of works. The grant application is going to be made for the greatest wall measure of all the eligible walls. So we have a situation here where we have a new extension at the back and to the side where it was built from 2011 onwards. We have the original building that was built prior to 2011. So the grant payment will be on the greatest wall measure of all the eligible walls. So the homeowner should apply for the grant for internal wall insulation, which is the green line, because the extension walls that receive cavity bead are not eligible because we're built from 2011 onwards. So it's just something to watch out for as well when it comes to, you know, claiming for homeowners, claiming grants and for the installation itself. We move on, and we're coming near to the end, to supports for contractors. And as I mentioned at the beginning, supports for contractors are available on the SEAI website. And again, we can circulate exactly where. And we're talking about, as part of your discussions with the homeowner, there is a homeowner's guide to ventilation document that the homeowners might find very handy in relation to achieving compliance in relation to ventilation. We also have that contractor's guidance note that we mentioned, something that I would probably have printed off in relation to what's installed. Mechanical ventilation waiver that we mentioned, again, that's an important document that's on the SEAI supports for contractors page. And also grant management for tips, grant management tips for contractors. And again, that might be some tips for you in there in relation to applying for grants or acting on behalf of homeowners. So again, I'd encourage you to download that particular document in relation to ventilation. It's definitely something that I would circulate among the installation team. And I would imagine if you are maybe inspecting your own work prior to install or prior to sign off, just to make sure that all these issues are looked at prior to sign off, prevent any reworks. And there's also additional supports or additional contractor training videos, including the roof insulation and other wall measures, etc. So available on the supports for contractors. So that brings me to the end presentation. Again, thanks for your time. If you have any